Hello, I am Sreja MR. I am working as lecturer in Department of Polymer Technology, Karnataka Polytechnic, Mangalore. I am interested by Department of Collegiate and Technical Education, the course of Elements of Chemical Engineering, third semester. Now, recap of session 2. We dealt with inclined manometer, differential manometer, YouTube differential manometer, and problems in the previous session. In inclined manometer, the manometer has a vertical leg and another leg, right leg limb of the manometer is inclined at an angle of 5 to 10 degree with the horizontal. We can measure very low pressure differences in inclined manometer. Differential manometer. Differential manometers are used to record the pressure differences between two different points on the same pipe or two different pipes. We also dealt with YouTube differential manometer for the same purpose, for getting pressure differences between two points in a pipe or two different points. We also dealt with one or two problems. Today we are going to discuss the following topics. One is fluid flow phenomena, Reynolds number, and Bernoulli's theory. So let us go to the first one, fluid flow phenomena. In fluid flow phenomena, there are two types, laminar flow and turbulent flow. First we are going to deal with laminar flow. So laminar flow, we are considering a liquid whose streamlines are separated from one another over the entire length of flow. Means they are at very low velocities. Fluids with very low velocities are said to be in laminar flow. The streamlines of the fluid will be parallel to each other, and such a condition the flow will be smooth. It is also called streamline flow or viscous flow. So once more, the flow in which streamlines remain separated from one another over the entire length of flow is called laminar flow. It is also called streamline flow or viscous flow. This type of flow takes place at very low velocities. When the fluid is flowing at very low velocities, laminar flow occurs. Then turbulent flow. Turbulent flow is the flow in which there will be disturbances in the flow. The flow in which fluid moves in form of cross currents or eddies is called turbulent flow. So here in this type of flow there is disturbance and fluid moves in a irregular pattern. This type of flow occurs at very high fluid velocities. So this is the fluid flow phenomena in which laminar flow and turbulent flow diagrams are there. You can see these are the streamlines. The streamlines in laminar flow are parallel to each other. Such flow is called laminar flow or viscous flow or streamline flow. Turbulent flow. In turbulent flow we can see the streamlines are in different paths. They are irregular. There is swirling in between. So regular flow is called turbulent flow. And this type of flow occurs at very high velocities of flow. Next we come to Reynolds experiment. It was first conducted by Sir Osborne Reynolds in 1883. So this experiment we can distinguish the different types of flow like laminar and turbulent flow. We used this experiment to distinguish between these two types of flow. To demonstrate difference between laminar and turbulent flow, this experiment was used. Now let us see the experimental setup and the procedure. So this is the figure diagram of Reynolds experiment setup. You can see a constant head glass tank with fluid in it, a dye tank. This dye tank has a water soluble dye in it. So there is a valve, pinch valve, from which this water soluble dye is introduced into this glass tube through a capillary. So in this dye tank there is a water soluble dye. A constant head glass tank is there, a glass tube for making the flow visible, it is there. This glass tube has a flat entrance. So Reynolds experiment, this setup consists of a constant head glass tank. As you saw in the figure, consists of a constant head glass tank. A water soluble dye is introduced into the flow of water using a small capillary tube. At low flow rates, the filament or thread of colored water flowed along the stream of water in straight line. So inside the glass tube, we will see at low flow rates, we will see a colored filament. The color of the water soluble dye, say if it is red, we will see a thin red filament passing through the flat entrance into the glass tube. It will be clearly visible that the thread of filament is passing or flowing. We are first adjusting the speed at very low rates. Then we can see a colored thread or colored flow of the dye. Now it will be in a straight line as the flow is in very low velocities. The filament will be in a straight line. Filament or stream of water will be in a straight line because the velocity is low at low flow rates. The flow rate was increased and a critical velocity was reached. The flow rate, we had increased the flow rate, then a critical velocity was reached. What happened when we increased the flow rate? There was turbulence in the glass tube. The flow became turbulent. Means after mixing, the color disappeared. This is an example for turbulence. Mixing occurred in the glass tube and the color of the dye disappeared since it is a water soluble dye. Oscillation occurred in the colored filament. Thread of colored water became wavy and gradually disappeared in the tube. Turbulent flow is characterized by rapid movement in random directions. So first we saw a filament of colored filament passing at low flow rate. We increased the speed of the water soluble dye. Then we saw rapid movement, turbulence occurring, and slowly the colored water disappeared in the tube. So turbulent flow can be characterized by rapid movement in random directions. So what is critical velocity? The velocity at which flow changes from laminar to turbulent is known as critical velocity. So the term critical velocity is the velocity at which the flow changes from laminar to turbulent. So this is the equation. In Ra or Reynolds number is equal to d u rho by mu. D is the diameter of the pipe, u the fluid velocity, rho density of the fluid, mu viscosity of the fluid. So Reynolds number depends on all these factors, namely the diameter of the pipe M, it is expressed in meter, U, which is the velocity, average velocity meter per second, rho, density of fluid in kilogram per meter cube, mu, viscosity of fluid, kilogram meter second, or Newton second per meter square, or Pascal seconds. NRE or Reynolds number is equal to d u rho by mu. So we know Reynolds number is represented by NRE if the number is less than 2100, the flow is laminar. If Reynolds number is less than 2100, the flow is laminar. Reynolds number above 4000, it is turbulent. It is denoted by NRE. So, if the flow of the fluid flow, the Reynolds number we can calculate, it is less than 2100, it is said to be laminar, and if the Reynolds number is above 4000, it is said to be turbulent. It is denoted by NRE. Bernoulli's theory. Next we come to the topic Bernoulli's theory. So Bernoulli's theorem states that for any fluid which is flowing as an ideal fluid which is incompressible, the total energy at any point of the fluid will be constant. If you consider a fluid flowing through a pipe at different heights, the total energy, that is sum total, the total energy comes as pressure energy, kinetic energy, atom energy, all three types added, this is the total energy. On any point of the pipe taken, it will be a constant. It states that in a steady ideal flow of incompressible fluid, the total energy at any point of the fluid is constant. The total energy consists of 1. Pressure energy, kinetic energy, potential energy, or atom energy. So, total energy of ideal flow liquid will be a constant, and it is a sum of pressure energy, kinetic energy, potential energy, or atom energy. So, pressure, it can be denoted by P by rho g. P is the pressure, P is the density, G is the acceleration due to gravity. Kinetic energy, it can be denoted by half V squared by G or V squared by 2G. Atom potential energy as Z. So these are the three energies. Then according to Bernoulli's theorem, P by rho G plus Z plus V squared by 2G is a constant, since the energy is the sum total of pressure energy, kinetic energy, potential energy. Potential energy is also called as atom energy. Pressure energy. What's pressure energy? Pressure energy is the work done on the fluid. Now we are going to derive a small derivation for how we obtain the different type of energies as stated in the Bernoulli's theorem. So, pressure energy is the work done on the fluid. What is work done? Work done is force into displacement. Work done on the fluid is force into displacement. This can again be written as force. We are multiplying the numerator and denominator by area into displacement. Force into area into displacement, totally divided by area. Now we know that force by area is pressure and area into displacement is volume. So pressure energy can be described as pressure into volume. So pressure energy per unit mass equal to Pressure energy is pressure into volume. Pressure energy plus unit mass equal to pressure into volume. It's per unit mass, so divided by mass. So it can be written as, for pressure P, and what is mass by volume? Mass by volume is density, rho, joule per kilogram. This is the SI system unit of pressure energy. Next is kinetic energy. Kinetic energy is the energy of the fluid which occurs due to its motion. It's the energy of the fluid by virtue of its motion with reference to some fixed body. So, when the fluid is moving, it possesses kinetic energy. It should be taken with reference to some fixed body. Kinetic energy of fluid of mass m. We can consider a fluid of mass m flowing with velocity u. Then kinetic energy equal to half mu squared. Kinetic energy is denoted by half mu squared. Half mu squared, where m is the mass and u is the velocity. Now we will see kinetic energy per unit mass equal to, we are going to divide the kinetic energy by m. Then m get cancelled. It is half u squared. Kinetic energy per unit mass is half u squared. Its unit is joule per kilogram in SI system. So kinetic energy is the energy of fluid due to virtue of its motion. Now potential energy. It is the energy of fluid due to position of Earth's gravitational field. Due to position of Earth's gravitational field. Gravitational field exerts an energy on the fluid, and that energy is called potential energy. It is equal to work done on the fluid to raise it to a particular height z above that level. The potential energy can be also defined as energy required to raise the fluid to a particular height above greater level. Potential energy can be also written as mgz. Z is the height. Z is the height, m is the mass, g is the acceleration due to gravity. Then potential energy per unit mass can be given as, we can cancel m when it comes per unit mass. It is showed as G is at joule per kilogram in SI. So, what is potential energy? Energy possessed by the fluid due to presence of the Earth's gravitational field. Or it's the energy work done to raise it to a particular height above the delta level. So, Bernoulli's theory states that pressure energy plus kinetic energy plus datum energy equal to a constant. When applied between two stations 1 and 2 in a fluid flowing through a pipe, so we are considering two stations of fluid flowing through a pipe. We can written as, one session is taken as 1, second one is taken as 2. It can be written as P1 by rho g plus U1 squared by 2g plus Z1. We are considering it at different heights. So, plus Z1 equal to P2 by rho g plus U2 squared by 2g plus Z2. So, this is the Bernoulli's theorem. In any two stations of a pipe, fluid flowing through a pipe, the pressure energy, kinetic energy plus datum energy is a constant. So, this is the both the energies in two different pipes are constant. So, one problem on Bernoulli's equation. So, let us see, water is flowing through a pipe of 5 cm diameter under a pressure of 29.43 Newton per centimeter square. So, through a pipe of 5 centimeter diameter, a fluid is flowing with a pressure of 29.43 Newton per centimeter square. The mean velocity is 2 meter per second. The velocity is 2 meter per second. Find the total head or total energy per unit weight of water at a cross section which is 5 meter above the datum line. So, Z is 5 meter. Velocity V or U is 2 meter per second. Then pressure is 29.43 Newton per centimeter square. Both centimeter has to be converted into meters. 5 centimeter diameter of the pipe. Let us come to the solution. Diameter of the pipe is 5 centimeter. It can be written as 0.5 meter. Pressure, it is 29.43 Newton per centimeter square. It can be written as 29.43 into 10 raised to 4 meter square. Now the velocity is 2 meter per second. Height is 5 meter. Now we know that total energy according to Bernoulli's theorem is pressure energy plus datum energy plus kinetic energy. Pressure energy is P by rho g plus Z plus U square by 2g. This is Z is datum energy. Kinetic energy is U square by 2g. Now putting the above data, we get the answer as for the question. Now coming to MCQs. So if the Reynolds number is less than 2100, the flow will be A. Laminar, B. Turbulent, C. Parallel, D. Tangent. So if the Reynolds number is less than 2100, the flow will be laminar. Name the velocity at which flow changes from laminar to turbulent. What's the name of the velocity at which flow changes from laminar to turbulent? Neutral velocity, critical velocity, laminar velocity. The answer is critical velocity. What is the energy of fluid due to position of Earth's gravitational field? What is the name of the energy of the fluid due to Earth's gravitational field? Kinetic energy, potential energy, pressure energy. So this potential energy. Fourth one, which type of flow, cross currents or eddies occurs? Laminar, turbulent, parallel, tangent. Which type of flow, cross currents or eddies occur? Laminar, turbulent, parallel, tangent. Answer is turbulent flow. Mention the unit of viscosity. Newton second per meter square, meter per second square, gram per centimeter square. Unit of viscosity. The answer is Newton second per meter square.